Hey everybody, it's Mr. Carr again, and we're going to talk about 3.3 day 2. We're going to continue our work with using scale factor, but now we're going to be focusing on things like perimeter and area. Last video we talked about just side lengths. Today we're going to be talking about perimeter and area. So when we look at these, first thing we want to identify is what is the linear scale factor of A to B? And it doesn't matter which one I pick, so I'm going to take 4 and 8, or I could take 12 and 24. They reduce to the same thing, which is 1 over 2. So that is my scale factor of 1 over 2. The next thing I want to do is I want to find the perimeter of each of these shapes for A and B. So since these are rectangles, I'm going to fill in these other side lengths here. Okay. And I'm going to, remember, perimeter is just adding up all the sides. Okay. So that's what perimeter is the sum of all sides. There are shortcuts with this, but I'm just going to go ahead and do 4 plus 12 is 16, plus 4 is 20, plus 12 is 32. For triangle B, I'll do the same thing. I'll do 24 and 24 is 48, plus 8 is 56, plus 8 is 64. Yep, 64. Okay, area. Remember, area is length times width. So for the first rectangle A, that is 4 times 12, giving me 48. Okay, rectangle B is going to give me 8 times 24. That's going to give me, what is that, 32 and 160, 192. All right. All right, so from there, find the following ratios. Remember, the linear scale factor is what I just said. So that was a 1 to 2 ratio. The perimeter ratio, if I look at the two perimeters, that's 32 to 64. Okay? But that I can reduce. That can actually reduce to 1 to 2 again. So area is going to be, let's see, what do we have? 48 to 192. That one can also be reduced. So if you're having trouble like reducing your fractions, it's okay to take them step at a time. So for example, if I take 48 and 192, divide them both by 2, that's going to be a 24 to, let's see here, 192 divided by 2 is 96. I'm not 100% sure yet, so I'm going to take both of those and divide both of those by 2 as well. So I divide by 2, that's going to give me 12. Divide by 2 is going to give me 48. 12 and 48, that's more familiar. Now I'll divide by 12. 1 to 4. So I'm going to pause the video right here. I want you to focus on this. 1 to 2, 1 to 2, 1 to 4. Linear, perimeter, area. What are your observations? I want you to answer both my questions now. What do you think about the comparison of linear scale factor to perimeter scale factor and linear scale factor to area scale factor or area ratio? Okay, now that you're back, here's the two main ideas today. Perimeters of similar polygons. If two polygons are similar with the lengths of corresponding sides as A to B is our ratio, then the ratio of the perimeters is also A to B. That's it. Okay, so now this is kind of a repeat. Like if I could find any, in this scenario, polygon 1, polygon 2, if I can compare their side lengths, their corresponding sides, and it's in this ratio of A to B, the ratio of the perimeters is also A over B. Now compare that to areas of similar polygons. If two polygons with the lengths of corresponding sides and the ratio are A to B, then the ratio of their areas is this. When I look at 1 to 4, compare that to 1 to 2, that is A squared to B squared. Okay, so again, side lengths are A over B, but areas are then squaring it. That's our scenario. That's our two main ideas today. Perimeter and linear scale factor are the exact same ratios, but side lengths and areas are not. It's the square of them. So whatever A over B is A squared and B squared. So let's take a look how that looks on here. So if I have these unknown shapes, but I know their scale factor is 2 to 3, perimeter is easy. It's the same exact thing. Area is going to be the square of that. So 2 squared and 3 squared. 4 to 9. Okay, next example, 5 to 6. If I go backwards here to the linear scale factor, doesn't matter, same thing, 5 to 6. But then when I go this way, I'm going to take 5 squared and 6 squared, which is going to give me 25 and 36. Okay, for my last one, I have to work it backwards. Now, I could, like, to think about it this way, how do I turn a squared over b squared into a over b? Well, to get there, I would square root both of those. And I could do that here, but it's going to get ugly with 8 and 32. So the first thing I'm going to do is reduce. Divide both by 8, I get 1 and 4. Now it's a lot easier to go backwards. I'm going to take the square root of 1 over the square root of 4, which is 1 over 2. And then linear matches up. That's it. Okay? So, example 2 here. Find the perimeter of similar figures. This is how we use those things. And this is a good habit to be in, is that you want to set up your ratios, identify which one you need to use, and then use that to find your missing piece of information. So for example, here's the 2 triangles that are similar. Find the perimeter of WXY. Now, normally you find perimeter, you just add 3 sides up. I don't have that here though. Okay, so I'm instead going to start off with the linear scale factor. That's going to compare 40 over 72. Okay, if I reduce that, I get 5 over 9. So that is my linear scale factor is 5 to 9. My areas, if I square that, that's 25 and 81. All right. Now in this problem, I actually don't need this, but it's a good habit to make sure I identify the ratio of the areas. Okay. Now my linear and perimeter are the same ratios. So that's what I'm going to write down now for my work. 5 over 9 is going to equal to so this is small over large, the unknown perimeter, which is x, and then the known perimeter, which is I'm just going to add those 3 up. So 72 plus 63 plus 81. Now remember, this is my linear scale factor or perimeter scale factor. They're the same. Small over large for the actual perimeters. Now we can cross multiply. 9x is equal to 5 times 216, which is 1080. Now we can divide by 9, so then I can get 120. That is my perimeter of the smaller triangle. It is 120. Again, the steps were identify the linear scale factor, step 1. Use that linear scale factor as my perimeter scale factor to set up this other ratio as my step 2. Step 3, solve that proportion. Okay, it gets a little bit trickier is when we do stuff like this, finding the areas of similar figures. Okay, now when I find the areas of these two, the ratio of the areas of 2 circles is 9 to 16. This is what I know. All right. Oh, I don't like this problem. This is not enough. We're gonna have to do one of the u-triangles for sure in the video. So normally I would say is when you go backwards now, I would take the square root of everything. So you would take the square root of 9 and the square root of 16. Square root of 9 is 3. Square root of 16 is 4. Okay. Now, again, I don't need that information because the question is saying what is the area of the smaller circle? Well, I already have all the information I need. Small over large. Small is the unknown area, so I'll just call that A. 68 is the known area, so I'll put that on the bottom there, small over large. So we've got 9 times 68, 16 times A. Multiply those together, I got 9 times 68, gives me 612. Divide by 16, and I get 38.25, what do I have, square feet. Now, what I don't like about this one is you're not doing a lot in terms of having to move back and forth. So, for example, here we go. This is a good one. The ratio of the areas is 8 to 50. So first thing I'm going to do is I'm going to reduce those. Okay, 8 to 50, if I divide by 2, is the same as 4 to 25. Now, you're given these boxes. I'm going to do a slight modification of that because I like to think of them as, I call it a SPA box. okay? It's a very similar idea. I'm just trying to fill in ratios here. The ratios of the areas is 4 over 25. If I go this way, I'm going to take the square root of everything. So square root of 4 is 2, square root of 25 is 5. And I compare the sides, and I should explain, SPA, S-P-A, sides, perimeter, area. So I know that sides and perimeter always have to match up. Area and perimeter are square roots of these, or going this way, it's a square root. If I went the other way, I'm squaring it. So here's how this is important. If the perimeter of the smaller square is 25, what is the perimeter of the larger square? Most common mistake I see in problems like this is trying to use the 8 over 50 with the perimeter here, okay? So instead of using the 8 over 50, I want to use 2 over 5. I'm using 8 over 50 to identify 2 over 5 as my proper ratio. So if I do 2 over 5, and again, that's small over large, perimeter of the smaller is 25. What's the perimeter of the larger? So I'll call it P. There it is. So I did not use the original ratio. I reduced that to make things easier. Then I filled that in. That's my area. That led to my perimeter. If you use the original one, I'm going to do the same thing. 4 to 25. If I go this way, I'm going to square root both. So I'm going to get 2 to 5. Doesn't matter which one you want to use. Just remember that linear scale factor and perimeter ratios are the same. All right, so now I'm going to cross multiply. So that 2p is equal to 5 times 25. 2p is equal to 125. Divide by 2, and I get 62.5. Can't right there. Going too quick. 62.5, and that's meters. All right, that's it for today. The other You Try Now problems, I want you to try them on your own, but we will talk about them together in class. All right, and that's it. So have a nice day.